Welcome to Harmony Learning Academy. Today we are going to learn about some of the basic formulas of differentiation. If you have not seen our previous video on differentiation introduction, then please watch it and then continue through this video. The link of the previous video is given in the description below. From the previous video we know that f dash x equal to limit h tends to 0 f of x plus h minus fx by h. Okay, so first let us consider the function fx equal to x. Therefore f dash x equal to limit h tends to 0 x plus h minus x by h, which is equal to limit h tends to 0 h by h equal to 1. So let us now consider a function fx equal to x to the power n. Now we have to find the derivative of fx, so it will be f dash x equal to limit h tends to 0 x plus h whole to the power n minus x to the power n by h. Okay, now we have to do the binomial expansion of x plus h whole to the power n. So it will be n c0 x to the power n plus n c1 x to the power n minus 1 h plus n c2 x to the power n minus 2 h square plus n c3 x to the power n minus 3 h cube, and it will continue like this till n cn x to the power n minus n h to the power n. Okay, if we put this binomial expansion here, we will get limit h tends to 0 x to the power n plus n c1 x to the power n minus 1 h plus n c2 x to the power n minus 2 h square, and like this we'll get till n cn x to the power n minus n h to the power n minus x to the power n by h. Now the first term and the last term cancels each other because nc0 x to the power n is nothing but x to the power n. Now what we are left with is that limit h tends to 0 nc1 x to the power n minus 1 h plus nc2 x to the power n minus 2 h square up to ncn x to the power n minus n will be x to the power 0, which is 1, h to the power n minus 1 divided by h. Now if you cancel all the terms of h, we are left with the following: limit h tends to 0 nc1 x to the power n minus 1 plus nc2 x to the power n minus 2 h plus nc3 x to the power n minus 3 h square, and like this we will get till ncn h to the power n minus 1. This will be h to the power n. Okay, Now we have cancelled h, and thus we no need to divide it by h again. So we will have, now see, as h tends to 0, all these terms will be 0. Thus we are left with n c1 x to the power n minus 1. Now we know nc1 is nothing but n factorial by 1 factorial by n minus 1 factorial x to the power n minus 1. So this will be n into n minus 1 factorial divided by n minus 1 factorial x to the power n minus 1. This cancels out and we are left with n x to the power n minus 1. Let us now consider another function fx equal to sin x. So f dash x will be limit h tends to 0 sin x plus h minus sin x divided by h. We have sin x plus h equal to sin x cos h plus cos x sin h. This is a trigonometric relation. Thus, putting it in our formula, limit h tends to 0 sin x cos h plus cos x sin h minus sin x by h. If we now put h equal to 0, so cos 0 will be 1. So thus limit h tends to 0 sin x plus cos x sin h minus sin x by h. And this sin x and sin x cancels out each other. We are left with cos x limit h tends to 0 sin h by h. Now we all know that limit x tends to 0 sin x by x equal to 1. This is a standard limit. Using this formula, we can say that cos x into 1 equal to cos x. So f dash x will be cos x. Let us now consider the function fx equal to e to the power x. E to the power x is the exponential function. So f dash x will be limit h tends to 0 e to the power x plus h minus e to the power x by h. So we can write limit h tends to 0 e to the power x into e to the power h minus e to the power x by h. So it will be limit h tends to 0 e to the power x e to the power h minus 1 by h. Now e to the power h is an exponential function, and we can write e to the power h equal to 1 plus h by 1 factorial plus h square by 2 factorial plus h cube by 3 factorial, and this will continue up to infinity. Therefore e to the power h minus 1 will be h by 1 factorial plus h square by 2 factorial plus h cube by 3 factorial up to infinity. And e to the power h minus 1 by h will be 1 plus h by 2 factorial plus h square by 3 factorial up to infinity. Now if we put the limit h tends to 0 e to the power h minus 1 by h, we get that 1 plus this all terms limit h tends to 0 h by 2 factorial plus its square by 3 factorial up to infinity. Now as h tends to 0, all these terms will be 0, so it will be 1. Thus, returning back to our previous formula, it will be, we get e to the power x limit h tends to 0 e to the power h minus 1 by h, and we have already calculated limit e to the power h minus 1 by h equal to 1, so it will be e to the power x. So derivative of e to the power x is also e to the power x, so f dash x equal to e to the power x. Let us now sum up what we have learned. When you have fx equal to x, then the derivative will be 1. When we have fx is equal to x to the power n, the derivative will be n x to the power n minus 1. When we have fx is equal to sin x, it will be cos x. And when we have fx is equal to e to the power x, the derivative will also be e to the power x. So in the description below, I have given a PDF file where you can find all the other basic formulas that are required for differentiation. Thank you guys for watching this video. I hope you like it. Please subscribe to my channel.